You can also apply the diode with an AC source, and it creates a unique output. When you apply an AC source to the anode, we know that the AC source, the voltage changes. First it starts off positive, and then it reverses and goes negative. So for an AC source, on the positive cycle, the diode would be forward bias, but on the negative cycle, the diode would be reverse bias. What that means is that on the positive cycle, there will be current flowing through the diode, allowing a voltage to be dropped across the load. However, when the diode is reverse biased, there will be no voltage drop across the resistor, because we know that in the reverse bias mode, there is very little current flowing through the resistor. So that means you'll get very little voltage. So the output voltage measured across the resistor will look something like this. And we call that a rectifier. And since we're only recovering half of the signal, we call it a half wave. Since we're dealing with an AC power source, we have to go to another measurement called the average value. And the average value that you get from this calculation, depending on calculus, is V peak divided by pi. So if you know the peak value, then you're able to calculate the average value. Sometimes you'll have a dual power supply like this, where they'll have the same values at the same phase. And when you put them in series, you can connect the center to ground. In this operation, on the positive cycle, the diode will conduct. The first diode will conduct. But on the negative cycle, the second diode will conduct, which means that the resistor voltage will get a voltage on both cycles. You're still getting a rectified voltage because all the voltages are positive, but this time we call this a full wave. And the formula to estimate the average value for a full wave is 2V peak over pi. In the next video, we'll do 2 examples so that you get the idea on how to do the calculations for the circuit.